Thank you. And Aiko promised me all the time left by the other speakers, so I've been making all sorts of obscene hand gestures to make them stop, because now it's only me between you and lunch. And what I will talk about, well, I will actually try to take a bit of a step back and to end by asking now, what does all of this mean in terms of applied biomonitoring? What does this mean in terms of how we should be following the state of the environment and sound the alarm when things are changing? Because I do feel that I myself, and I believe many of you, sometimes imagine yourselves in a role like this, that you are the experts who can read part of the environment and see which way things are heading, and and also try to, as Fredrik was saying, try to see how different options, how different things that we do to our environment, how they actually affect biodiversity. And this thing used to be simple, and I'm afraid that much of current approaches to making this happen, they're actually based in the Swedish 18th century view of the world. Because in the 18th century, the world was very small. The most famous biologist, Swedish biologist to date, Carl von Linné, he imagined that there was something like maybe 1,300 species of plants, and let's make it about 1,400 species of animals. And of those, the main part were fairly large and easy to observe. And it didn't get much worse globally either, because in the world maybe there are some 20,000 plant species and some 20,000 animal species. Now, we can easily keep count of all of those in a way much envisaged like this. But then again, the view that we have been trying to present today, it doesn't quite look like this anymore. It looks more like this. From those maybe 20,000 animal species, we're now talking about a global biodiversity, a global species richness of, let's make it 10 million species. And what's worse, the white parts within those animals and plants and protozoa and fungi and algae and you name it, they are still to be discovered. Every time we go out, we find new species, and we realize what we thought we knew about the world wasn't complete. And if we thought that much of biodiversity was large and flashy and easy to monitor, then the view that we've been showing you today is actually this. This is what biodiversity looks like. These are the dominant species of the world. Fredrik used some ugly words to describe them. They are actually super attractive, but they are small, and they are very hard to tell apart, most of them. We've been talking mainly about insects today. There are, we have to admit, also other organisms in the world. This is another view of global biodiversity. This is a super diverse kingdom, the fungi, and these are the flashiest members. They also tend to be small, nondescript, and hard to tell apart. But then you will tell me, well, we still know a lot about the state of these things. We have loads of data. Right? Well, if you look at simple numbers, we have plenty of data. This is a representation of the global biodiversity data that we have. We actually have records of species occurring somewhere in the billions. We have hundreds of thousands of data sets, and much of the world is lit up in these very warm colors because we have plenty of data. And it's only when we scratch the surface that we realize that this may not be representative of the actual state of the world. If we take the GBIF data and we actually look at the relative representation of different species, here with the pictures drawn in proportion to how many records we have, well, GBIF is an excellent database on birds. Birds are a bit of an evolutionary joke. There are about 10,000 species of birds in the world. The state of the birds will tell us nothing about the state, well, very little about the state of the world. This is what the world looks like in terms of biomass distribution. We've been talking about arthropods to date. Annelids, they tend to be fairly weighty too, and this is for animals alone, so I won't even include the plants and the fungi. They would be super large. So this is not a map of global biodiversity. This is a map of human interest and investment in finding out particular features of particular groups. Now, what we need to remedy the state is one thing. That is standardized, taxonomically comprehensive. That means that we actually look at all groups at actual biodiversity. So we bring the diversity back into biodiversity. And we need data generated not by who happened to go out and look for something, but by known sampling processes. Because otherwise, the data that we have will reveal very little about the underlying patterns in biodiversity. Now, what does this call for? It calls for things that we have tried to describe today, and I think IBA serves as a template for how to approach these things. Now, what we need are new ways of working together. IBA, remember, was based on volunteers, many of whom are here, who spent a full year, every week of that year, to go out, sample the insects. That's how we got to the thousands of samples. So a distributed design with then the material flowing into these guys at the front row who did the actual analysis. There would have been nothing to analyze without those volunteers. And this model can actually be scaled up. We can do this at the scale of the entire world. We are doing this at the scale of the entire world. We can go across taxa. We've been talking about this type of sampling devices. Well, we can also sample fungi from the air with like a big vacuum cleaner like that. We can sample the soil, and if you insist on those birds and mammals, we can do that by, for instance, listening to them or taking pictures of them. So we can do this across taxa. We can get to that taxonomic coverage. And we are actually doing that across the world. These methods are being implemented at all of these sites in black, and then at actually sampling is continuing at the IBA sites in Madagascar, which is just fantastic. We are now getting up to a 6-year time series for those sites, and we are continuing sampling across the Nordic countries at smaller and smaller and smaller scales. And everybody who gets up here has been bragging about large numbers, so will I. So I mean, we're up in the millions of images. We're in the hundreds of years of audio recordings, tens of thousands of air samples for fungi, and tens of thousands of malaise trap samples. And just to illustrate the scale of the data, somebody mentioned 2 years of music playing. Actually, in this case, I calculated how much sequence data we are generating. The fact is that if you took all of the sequence data and printed it at font size 12, it would go 15 times to the moon and back. So that's some serious data. And what we are finding is exactly this view of an unknown world. So this is a picture by Brendan, the gentleman in the hat, looking at, you go out and you suck some sample of the air. Now, how many of the fungal taxa that you are recording have you seen before? And the fact is that if you look at the level of species, then most of the things that you are finding is either something that has never been seen before or likely has not been seen before. And then you say, oh yes, but that's because tropical diversity is so high, that's where all the diversity is hidden. Well, Fredrik just told you about discovering 10,000 new insect species in Sweden. And Brendan calculated that if you go out and suck an air sample from the city center of Stockholm, about half of the things that you find in there have never been seen before. That's the extent of it. So I think the impression that we want to leave you with today is of a new world. It's a world where actually most species are still unknown, which is not a small nicety somewhere that it's easy to find new species, but it actually means that dealing with the unknown is as important as dealing with the known, if we want to make sense of which way the world is heading. And the other message that we've been trying to convey is that, okay, finally, we know the way forward. It's not like we are stunned by this diversity and saying we know nothing about the world. We're saying, hello, we together, of course, with other teams around the world, we just created the tools for dealing with this. So I think where that leaves us is that the thought that we need new methods, we need new ways of approaching things, we need new ways of working together, including volunteers and crowdsourced initiative. And not only we need them, we just came up with these solutions. And the feeling that I think we want to leave you with is that, well, it was kind of cool to live in the days of Carl von Linné when nothing was discovered. Well, I tell you what, that was nothing compared to the age of discovery that we're living now. I think this is the most fascinating time ever in natural sciences, and I hope that's part of the impression and the feeling that we have managed to convey to you today. And with that, I think we are done, and now there is nothing to stop you from going to lunch. Thank you very much.